Hello everyone, welcome to our channel. In this video, we will be going over how to show or how to infer some of the descriptive statistics from the data that we have loaded. So first, let me, without further ado, get started. First, let's just clean this text, load libraries, and this will be loading to dataset. And this part will be where we will be summarizing our data. Summarize data. And we'll start off with some of the descriptive statistics. And the reason I'm doing this is because if you move to the table of contents, you will soon see it being aligned. So whenever you want to add any libraries, you can click on load libraries, you'll be redirected to the libraries element. Now, first is the data.head. Let me run this once again. It pops out top 5 rows and we can infer some of the data. For example, here you can see the ERP and the ERP column are very closely interlinked, 198, 199, 132, 132. There are odd differences like 172, 253, row number 3, but on a high level you can say that these two columns are very highly correlated or linked to each other. Next, let's look at the shape of the data. So we have 209 rows and 10 columns which are VEN to ERP. Next, let's look at the types that we are dealing with, data.b types. So our VEN and MOD, which is the vendor and the model column, are objects, and you can confirm the same here. So vendor is advisor, AMDEL, model is 32 by 60, 470 V by 7, so on and so forth. And the rest, all of the values or all of the columns are integer types. Looks good. Next, let's describe the data. It will collate some stats across all of the numerical columns, which means count of the columns, so we don't have any missing value. We have the mean. Again, you can see mean is slightly different: 203, 2000, 11,000, 25, 4, 18, so on and so forth. So mean varies. In some cases, it's in 3-digit, 2-digit, single, even 4 digits. Deviation is the same. It also varies across columns. So it might be a good idea to transform these columns so that their mean and standard deviation could be brought down to a similar scale. Again, in this project, in this machine learning project, we will not dive deeper into transformations. We'll go over a high level view, but it's a good thing to keep in mind for future projects. Next, we'll look at the correlation of all the columns. Now we need to pass a parameter numeric only equals true, since correlation is generally only applied to numerical columns. Of course, we can convert these strings, vendor and model or objects, to numerics, but we will take a bit later. So here data.co correlation numerical true, and it pops out saying that the ERP, which is the one we will be predicting, is sort of inversely related to MYCT. It's highly 0.82 minimum main memory. Mmax, which is the maximum main memory, it's 0.9 correlation. Cache is 0.6 with cycles, minimum cycles, 0.59 maximum cycles, 0.9697 if I round off. PRP, again, as we could infer earlier from these rows, both of these columns are highly correlated. And finally, let's look at one more, which is the skew. So again, numeric only. And now it says 2, 3, 2, 4, 3, 3, 4. So in general, whatever number we are presented with, if it's positive, it means that the curve or the values of the column are right skewed. If it's negative, it's less skewed. In general, what we want to achieve is for this skewness to be as close to 0 as possible, which would mean that it depicts a bell-shaped curve or a Gaussian curve. So these are the descriptive stats for this dataset, and that is all in this video. In the next video, we will look at some of the charts that we can use to visually represent the data that we have looked so far. Thanks so much for watching. Bye-bye.